Yeah, but I need the video to sync up with the audio now. So now you're good.
Oh, true. Yeah, up, down, left, right. It is synced.
We're good.
Okay. So, hit new project if you haven't done that yet, and call it whatever the fuck you want. So, yeah, I'll just call it physics. I was trying to think of a clever name. Shut up. You could just keep it at default 3D, because we're doing 3D. Okay. So last week we did, or no, was it last week or 2 weeks ago that you did? Yeah, it must have been 2 weeks ago that we did Make Your First Platform, and that's where we did a lot of 2D stuff. And a lot of this translates into 2D by just using the 2D versions. And all it really does is limit it to 2 dimensions instead of 3. But let's start by making a floor. So if you go to Game Object, 3D Object, you can go to Plane, and that'll make a nice flat floor. Who is actually following along? Just curious.
Man, I'm listening.
You are? Are you?
Are you starting up on this computer?
Yeah, that one's all screwed up. Well, hey Jamil, how's it going? Okay. So, yeah, that's reassuring. So, we have a plane. So, if we make then a cube, this will be Jerry the Cube.
Hi, Jerry.
That's the name I'm giving him. I'll just center him and give him 5 up there. So, we can attach something called ye old rigid body. I'm going to be explaining a little bit of what a rigid body actually is and some of the different parts of it. So, first of all is mass. That makes it heavier. That's pretty simple. That should not be very hard. Drag is sort of the air resistance. So if you have, for instance, this isn't going to collide with anything. Oh, yes it is. Because never mind. Forget what I just said. I forgot about default colliders.
Yep.
Yeah, so this will just fall. It'll look pretty simple falling. If I increase drag to like 5, which is a lot, you'll see that it's a lot slower because it's got a lot of air resistance against it. Angular drag is what we'll look at in a bit. Angular drag is the basically resistance from rotating instead of moving. Regular drag is as it's moving, it's getting air resistance. Angular drag is when it's spinning, it's getting resistance. Gravity is whether it uses gravity. That should be pretty self-explanatory. Gravity is defined in Unity as just a constant force moving downwards at 9.81, I think, is gravity.
You can change that.
If you went to physics, you can change that. I forget where you do that, but you can. I think it's
project settings, physics, I think. Not important.
Yeah, okay. Yeah, true. So there is an option called is kinematic. And what a kinematic object means is, let me get a second cube. We're going to need another cube. What am I naming this one? Give me a name. QB?
QB.
All right, QB. Qbert. All right, hang on one sec. That's Qbert. That's Jerry. Cool. So if these fall, as they are now, neither of them are kinematic. They fall and they interact with each other normally. If an object is kinematic, basically what it means is nothing will interact with it physics-wise. It'll still exist, it'll still be there, but it won't actually be affected by anything else. What that's useful for is if you're making something that's translating, aka you're setting its position manually at a certain rate, you don't want it to be affected by other objects that are going to hit it. So you would make it kinematic so that other things can still interact with it, but it won't fall and be affected. What's up?
So, for example, maybe a moving platform?
Yes. Yeah, moving platforms you definitely want to be kinematic because you don't want the player to jump on the moving platform and the platform to start falling and then flip over, and that's not what a moving platform is supposed to do. That would be a fun game mechanic.
That sounds like Wipeout.
That does sound like Wipeout. That's actually what I was thinking when I was, yeah. So that'd be like a Wipeout situation. So So then there's some stuff that you probably won't have to worry about, these two, but I'm going to give a brief explanation. Interpolate is if your object is jittering really quickly, if it's not being stable, if it's like radioactive, or I don't know how Unity works with that, but
Unstable means.
well, it's unstable is my point. When it's not stable, when it's
like caught on, if it's like caught on the wall or something.
yes, if it's being screwed up, interpolate smooths out the motion using the frame before it. Extrapolate smooths it using the frame after. You shouldn't really have to use those unless something's going horribly wrong. Collision detection is how you want the engine to actually like look at things and like figure out where things are. And so if you have normal, not super fast moving things, you should use discrete. You should pretty much always use discrete. Continuous is good if you're doing fast moving objects that are going to collide with static objects, so like bullets to people. And continuous dynamic would be if you had two bullets hitting each other, basically, like two really fast objects hitting each other. That's where you would use that. But otherwise, you should really stick to discrete. There's no real need to do that. And then finally, there's constraints. Constraints freeze certain... Thanks, let me move this over. So if I were to freeze the X and Z position, that means it can't move along that axis. So it would not be able to fall off the side of that block because it doesn't have enough room, because it can't move in those axes. And if I were to freeze rotation, then it wouldn't actually fall off, even though it clearly should be falling off right now. And then once let's see, what is that, X? Then so that's what constraints are useful for. That's good for things like moving platforms and like the player. You don't want the player oftentimes to be flipping and falling over unless you're making quap or something worse. Yeah, that's kind of hard. So, let's just get these spread out a little bit. Okay. So we've got rigid bodies. Rigid bodies are pretty nice. They're just basically physics objects for the engine. So let's make a script that lets us mess with some of the values in a rigid body. So let's call this adding force and open it up. So basically, you can directly change a bunch of aspects of rigid bodies like velocity. You can add forces. You can add torque. Okay. Oh yeah, good point. Nice job. So here let's do some let's try and get some force to try and get an object to move. So if we set a rigid body, we did this 2 weeks ago as well. This is a good practice to get into, of making a rigid body and then setting it with get component, which will get the rigid body of the object that this script is attached to, with the weird caret things and the parentheses, because format. And then, so what we can do is, we're actually going to get rid of update, because there's a really nice shortcut that they've put in for things. It's called on mouse down. And basically it uses a ray from the camera to tell when the mouse is clicking on a collider. I'll explain rays in a bit. We'll get into that. So in here, let's add rb.addForce, and let's add, actually before we do that, let's make some variables for which way we're actually going to move it. So if we do public, a public variable basically will show up in the actual project when you're doing it in Unity, which means you can change values like speed without having to go into the script and like change it with code. You can just enter in the value you want. So let's give it a direction, and let's give it a value for how much force we want to give it. So let's make it direction times force, and that's it. So that's that script. So now if we go back here, and then we actually remember to add it in, that's always important. Then we can set the direction to be, let's say x is 1. So it's going just in the x direction. Which way? Towards us?
Towards us.
Let's make that -1. Good point. And then force, let's give it like 10. Probably won't move that much, but when we go into the game, yeah, this is the kinematic. Good point. It actually, I'm gonna move these so it's easier to see down here. So now when you click on the one that we gave the script to, I don't remember which one it was. It was this one. It doesn't have very much force on it, so if we increase the force, make it like, let's give it like 100. That should be something noticeable. There we go. So when you click on it in the game view, it adds that force, and you know you can give it a ridiculously high number and see it launch way into the distance. And so that's adding force, and you can change, of course, change direction. I can make it go straight up, give it 1,000. So when you click on it, it sort of jumps into the air. So that's adding force. Now there's another thing that can be kind of important, depending on what you're making, called force mode. So add force actually takes two things. It takes the vector that you're trying to launch it in, with including the magnitude, and it also takes something called the force mode. Now, if we do force mode dot, we can see the 4 types of forces that you can use. So if you're using force basically is useful for continuous forces, and it uses mass. So if you have a mass of 1 on an object and you launch it, it'll go so far. And when you have a mass of 5, it'll go much less because it's taking into account mass. Acceleration is for continuous movement, and it ignores mass. So if you give 2 objects, one mass 10, one mass 1, and you give them the same acceleration, they'll move the same way. It'll be uniform. Impulse is for instant forces. It takes into account mass, and velocity change is an instant change that ignores mass. So if we do impulse for an instant change that it takes into account mass, and then we go back here, and we give this direction z -101.
-1 would go towards us.
Towards you? Okay, yeah, then 1. I screwed that up. Then if we give this the same script, give it the same direction, and give it 100 or 1,000. Let's give it 100. Nah, 1,000. And we make one of the masses 5. You'll be able to see that one, that was a lot farther than I thought it would be. Well, that one did go slightly slower. It was kind of hard to see because, man, that was... Oh, that's right. Impulse. Because I did impulse and it's instant rather than continuous, it did go a lot faster. So let's turn that a bit down, see if we can get a better idea of what's doing what. So that had enough to go off, and this one barely moves because it's taking into account its mass. So that's basically adding forces in a nutshell. It's pretty basic, pretty useful for anything really physics related, for launching things. If you're making a cannon, you'd want to add a really big force. If you want the player to be a physics object that moves around, this is for movement. jumping. This would be for jumping. All sorts of things like that. So now I'm going to move into something pretty similar to add force, but works a little bit differently. So let's make a new script called adding torque. So if you guys have taken physics, then you know that torque is kind of a pain to calculate, but it's not very bad at all in Unity. And quick little disclaimer, Unity uses the left-hand rule, if you guys did that in physics, where if you hold out your left hand, you should all hold out your left hand. Whichever way is pointing up. Yeah, this is the left-hand rule. So whichever way your thumb is pointing is the direction that you would use, and whichever way your fingers are going is the direction it would rotate. So if you give it a vector of up, it'll rotate around the direction of your fingers. It's not really helpful for the video, but for you guys it is, because you can see what I'm doing. So if you wanted to reverse that, if you wanted it to spin the other way, you would give it directly down, because that would go this way instead. So if we want to do that, we can do a similar thing that we did for adding force. You can add rigid body RB, and then let's give it a spinning speed. So we have something that you can enter that will determine how fast it spins. And then in start, we're going to do this again. So everybody loves this. Get component, rigid body. So then something that's pretty useful for physics that you should really try and use as much as you can when you're doing physics is, instead of doing an update, you should be using fixed update. And what that does is it normalizes the frames, basically, so they're always the same length of time apart, which makes physics a lot less janky and goofy. It makes it a lot more uniform and consistent. So you should use that pretty much as often as you can. So we want to make a value that we want to spin at, okay? So if we create a float, we call it H for horizontal, and we can take the get axis. We can take the input from the axes, so we can make it so that when you're pushing left and right, the object spins left and right, and when you push up and down, it spins up and down. So if we then type in horizontal, that gives us the horizontal axis. So that goes from -1 to 1. -1 would be pushing left, 1 would be pushing right. So if we do that and then we multiply it by our spin speed, that gives us, so instead of 1, if our spin was 5, it would be going up to 5. And then also times time.delta time. Now, I didn't know what time.delta time was for like a year, because nobody explained it, and I was like, I should probably use it, I guess. Basically, all time.delta time is it is the time since the last frame. So what multiplying by time delta time does is it basically makes it so instead of adding, let's say, a force, if you wanted to add a force continuously, rather than add it every frame, it would sort of normalize it so it adds it per second, basically. So if you're adding 10 force, it'd be 10 force per second rather than 10 force per frame, because per frame kind of gets pretty convoluted when you're trying to calculate things, because it's not a very easy thing to work with. So then we're going to make basically the exact same line, except for vertical. So that way we have both of the values for when we're adding that. When we're adding the spin, we want the horizontal this way and the vertical. So now we can do the actual command, and this is going to look pretty much like the same thing. So transform.op. So there's some shortcuts in Unity for getting axes. So if you type in transform.up, basically what it means is it will take whichever way this arrow is pointing, because this is up relative to the object. So if this is rotated like this, it would be pointing in this direction, not straight up. So that's useful when you're trying to do relative directions rather than absolute directions. So rather than moving up in the actual world, it'd be moving up for that object. What's up?
So it'd be like a rocket ship that if you tip it over, it just go up.
Yes. Yeah. So rather than a rocket ship that turns sideways and goes up, because that makes zero sense, it would be turn sideways and then rocket into somebody probably or something. Which both are bad, so I don't know which one you'd rather prefer. But so then we can take this transform up, which is basically shorthand for writing a new vector that is like it's the relative vector. And then we can multiply it by our h value. So the left-hand rule, if we're looking at straight up, it would be rotating side to side, left and right, which is what we're looking for in the horizontal one. So then we can do the same line and make it transform dot right. Oh God, what did I do? Dot right. And right would be up and down, looking at it with the thumb hand, like with the left hand rule. So another quick thing, these also have force mode. I think, pretty sure. I forgot the comma. Oh God, I did a period, I guess. So these also have force mode, and they're the exact same. They work the exact same way with impulse, force, acceleration, and the default is force. I don't know if I mentioned that, but the default is always force. So we'll keep that as default force. That should be good for adding torque. So now if we take these, lose their gravity so we can actually see them spin, and we give it add torque with spin speed 10 and 5. Then when we are pressing the axes, so WASD, arrow keys, whatever, you can see that they will spin. So I'm pressing to the side right now, and they're spinning, and you can see the one is spinning much faster than the other, and then up. So if I turn these up a little bit, you can also, here's where we can also see angular drag in action. So if we increase angular drag by a lot, even though I increase the speed, it's actually making it much harder to spin. So if I take this and I turn this to 2, you can see it gets even slower as it's trying to move. So angular drag is, as I said, the drag for when it's trying to spin. So let's put that back down to 0.05 so we can see these really go. And that's basically as simple as adding torque would be. Now, what's up?
If you also set angular drag to 0, they won't stop, and that can come in handy sometimes.
Oh yeah, yeah,
So
that's
change
true.
one of them to 0,
And then let them go.
just let them go. You'll see one of them
That's right.
going, and then if you let go like on the keys,
Yeah, I'm not.
you'll see one of them will eventually slow down, but the other one will
Give that
just
a
keep
little
on going forever.
Yeah, that's a good point. So what are some, do you guys have any like ideas of where this would be really useful in a game? So let's say you're making a 3D platformer. Where would you want to have something that rotates like this? One example, you could have a rotating platform that spins, and that way you could basically just make it so that it's continuously spinning. You can make something where it's like a wheel, so you can have multiple platforms, like Mario 64 style, and then you could have them spin using this. That'd be a way to do it. You could also do, just by editing the rotation, that would be better for non-physics things, for if you were making it static. So it kind of depends on what you want to do, but physics can be pretty helpful. They should be pretty helpful. So now we've gotten things to move and we've gotten them to spin. But there's something else that's pretty important, and that's physics materials. We touched a little bit on this in the 2D platformer as sort of a side note to make it so you could slide off walls. But basically, when you can create a physics material, and it gives you a lot of options. So if you've taken physics, then you know that there is a coefficient for static friction and then for dynamic friction, and that's the exact same thing here. This is basically where you're setting them. So dynamic friction controls while it's moving the friction against it. Static is to get it moving. And bounciness is always fun. Bounciness determines whether something is going to bounce off of things. It's pretty self-explanatory. So if I take this and I give it the bouncy, I forgot to add gravity. Shut up. Yeah, I know, right? Just, it's tragic. So you can see that the one will bounce while the other one sits and doesn't really do much. So actually, interestingly enough, if you add one bounce on both of them, it will continuously bounce. I think it actually gets a bit higher each time.
I don't think it gets higher. I think it stays the same.
No, I think it's getting higher. It's starting to get out of frame.
Okay.
Will it get out of frame? Yeah. So, I mean, it doesn't follow our rules quite, but it lets you do things like bounciness, and if you, let's rotate this a little bit. And then, oh God, why did this open over here? And if we take this and we were to, for instance, increase the friction, I don't actually know what the max is. Is it 1? I would assume it's 1, but whatever. So if we were to give this if we were to give this the maximum amount of friction, you can't really tell because they're rolling. Okay, let's move those down a little bit so we can actually see that. Why did I use cubes?
Better than balls. Yeah.
Are they though? Would they be?
No,
I feel like balls would still be better. I'll rotate them, all right? Okay, one of them's doing what I want, where it's not going to move, whereas if I take this and I give it a 0,
Pick it up a little bit.
Yeah. Oh, this one also has that, so let's make them. Then it loses all friction, and it does that. So that's really useful when you are determining what you want your platforms to do. Come on. There we go. So that's really useful when you're determining what exactly you want your platforms to be doing. Because you might be looking for them to be bouncy. You might be looking for them to have a lot of friction. And that's really useful for games that are specifically physics-based. So that might not be that great in a platformer, where most of the movement is pretty simple. Friction might be sort of an afterthought. But in a game about mini golf, having a lot of friction might be really bad, or it might be what you're going for, and bounciness would be very important so that when your ball hits a wall, it doesn't stop, it bounces off like it's supposed to. So then the last thing I want to go over is probably the most complicated thing that I've been going over so far. It's called Raycasting. So we're going to make a new script called Rays for Days. Because shut up. Whatever. Why isn't this opening? There we go. So, rays are basically invisible lines that you shoot that can collide with things. So if you are making a game with a gun, this would be what would, if you made the bullets move instantly, this would be what you were using. So there's two ways to make a gun pretty easily in video games. One of them is to actually shoot a projectile and see what it hits. It's not usually very efficient because of how fast bullets are supposed to be moving. So if you were to make a game with a slow-moving bullet, that'd be great. That would work fine. But if you're making anything with a fast bullet, it would really be inefficient because it would not detect collisions correctly, because if it were to hit a really thin wall, it might move completely through it from frame 1 to frame 2. So it would not count as hitting it, and that's not what you want. So a way to get around that is to do rays. And what a ray does is it basically just shoots an invisible line from wherever you want, in whatever direction you want, and yeah. And it'll basically give you information on what you hit. It'll give you that object, and it lets you basically just snipe things. So what I mentioned earlier was in Add Force, all on mouse down does is it shoots a ray from the camera to wherever your mouse pointer is, and whatever it hits, that's what it interacts with. So every time I went to click on the cube to make it move, I was really shooting a ray at it and seeing if it hit. So rays look like this. Physics.raycast with, I'm just going to write out what it actually is and explain a little bit of the things. Okay, so yeah, getting around it. Okay, so the first two are the origin, which is the position that you're shooting it from. This would be the barrel of your gun. If you're trying to draw a ray to see how far you are from something, it would be going from whatever point you're trying to get. The direction is the vector that it is going in. So it would be transform.forwards if you were using a gun, because you'd always want it to be pointing forwards. You don't want that to move. You wouldn't want the gun to be tied to world space, for instance, in direction. That way it looks great when you're facing forwards, but once you turn left, you're shooting out of the side of the gun. So you want it to be consistent. So usually you want that to be relative to what you have, rather than absolute. So then you have, this is sort of the important one, Raycast Hit. So what that does is that will give you what you're hitting. So that is an object that will store the collider that you're hitting, and the collider is attached to the object. So it essentially gives you the object that you are hitting if it's hitting something. If it's not hitting anything, it won't give you anything. Then we have, I'm getting a little bit off screen, that's all right. Float distance, which is the length that you want the ray to actually be. If you don't put anything in here, it will be infinite, which doesn't usually result in too many bad things, but might want to limit that just in case. So that's the distance. And then finally there's something called layer mask, which you probably won't be using all that much. But what a layer mask does is it lets you make it so that certain things won't be hit by the ray. So for instance, if you're making a shooter and there's some smoke, you wouldn't want the smoke to count as an object to hit. I mean, you wouldn't put a collider on it anyways, but if you did for some unknown, ungodly reason, you wouldn't want the bullet to be hitting the smoke and bouncing off or anything. So you would make it so that whatever you don't want to hit is in a different layer mask, so that it's basically ignored, so you can shoot without actually hitting that. We won't be using layer mask because that's not really very necessary, but that's raycasting. It's not really that complicated, but it can be kind of weird at first. So let's make a distance. So we can make a ray that will shoot downwards to check if an object, to check to see if the floor is within a certain distance, and then we can have it do something. So at least that was my idea for this workshop. Great idea, I know. Lots of fun. So we can get rid of start, don't need that. So we can say, we can make, this is a little bit easier, we can make a Raycast Hit object to store hit. That is when we shoot the ray, that will store the information of the object that we're hitting. Then we can say if physics.raycast, God, I can't type. And then so the origin, so this is the position of the object that this is attached to. That's where we want it to start. Then we want vector 3 dot down. The reason we're not doing transform dot down is because if we're checking for the floor, we wouldn't want it to be rotatable when you're checking it, because if the object is spinning through the air, we wouldn't want the checker for the floor to be spinning with it, because that wouldn't really give us the accurate information that we want. So vector 3 dot down is absolute space. That is world space. So that's not relative to the object. That's in general going straight down. So then we can put out hit. That's giving us the information of the object we're hitting. Hit is storing it. So if we hit something, hit will be filled with the information of what we're hitting. And then make it distance ray length, which we determined up here. So, and if we hit that,
One more parenthesis.
what?
One more reference. Right.
Oh, yeah. I made that mistake earlier when I was writing this code.
Yeah.
It's too long of a line, I forget that. And then we can say, let's just make it really easy. Destroy this game object. So it will destroy what it's attached to once it gets within that certain distance. So if we attach that here, it's getting a little bit convoluted with these, and then we make it ray length 2. When we press play, you'll see that once it gets within a certain distance, it disappears. One of the problems, though, is you can't really tell what that distance is. It gets close, and then poof, it's gone. So one of the nice ways of checking it is Unity has this beautiful thing called debugging. Yeah, that's a programming thing. So what we can do is we can draw a ray with basically the same information. 3 dot down times ray length. So we can do basically that same ray, and then when we do it, you can see, well, you saw for a split second, that it actually draws the line, not in the game, but in the scene. So if, as we run through, we can see it's getting close, boom, it hits, and then it disappears, it dies. So that's really helpful when you're trying to actually figure out the distance for stuff, is to draw things. I think 2 weeks ago, we drew the little circle that told if we were above a platform so that you can see, okay, this is exactly where it is. Because if you accidentally make it way too far down and then you're confused because your platform's too thin, you want to make sure that you know exactly where it is.
I got 2 things also about that if you want me to go.
What's up?
So one thing you might have noticed is that line stayed there for an extra frame. There are some cases where the raycast is, the debug ray is drawn a frame after, which might mess up your eyeball method. I don't know why it does that, but if you were to change where the debug.log is located, maybe like after the if statement, I think it also, I don't know. It's weird how it goes, but yeah, it'll stay there. It'll stick around for an extra frame like there,
Yeah.
and then it'll just disappear the next frame. So just be aware of that if you're trying to eyeball it. Also, if you ever want to, if you're doing multiple raycasts or debugs, if you go back to the code, actually, there is a cool third argument inside of draw array, and that's color. So you can choose color, capital color, and then you can do color dot red or something like that. So you can actually label your lines as to what actually they'll look like.
That's a
So
good
if you have
point.
multiple rays we can draw in, you can help clarify like that.
Oh my God, it's red. Yeah.
That's all I got.
So that's a good point though. So another thing is we can also check to make sure that we're actually hitting the floor. So here's the floor. So we can tag it. We can add a tag of floor and attach it to the floor. And then here we can also check in here if, and this is where we're using the information of what we're hitting. We can say if hit.collider. So we're getting the collider of the object we're hitting. Dot tag. Dot equal. Is it better to do dot equals or equals sign?
I would do equals because it's a string.
I don't know.
Doesn't matter.
I never really hear which one's objectively better, so I was just curious if you had an opinion.
That I just kind of brought over.
Yeah. So then we can do, if it equals the floor, then it will destroy the object. So if it doesn't, it won't. Because if we don't have this, if I go back to when we didn't, if I comment that out real quick, and then if we were to take this, move it directly under, and then have it not use gravity. Right now, it would be destroyed against this object. We don't necessarily want that. We want it to be destroyed when it hits the floor. So we can specify that it'll only be destroyed if it hits an object with the floor tag. That way it will fall and only be destroyed once it actually hits the floor, or once it gets close enough to the floor. And another way of doing that, if we didn't want to do that, is we could give it a layer mask so that only one of those objects was able to be hit by a ray. So that's also what you can do. So that's basically all I had for this, was just
Back to the code real quick.
the simple physics
You never
stuff.
mentioned it, but it's worth mentioning that
Yep.
physics.raycast returns a bool, true, false. If it's true, it means it does hit something. That's why I put it in an if statement. So we'll only ever get into the inner if statement and the destroy if it actually does hit something, and that does depend on the ray length.
Yep.
So
That's,
I mean, it's pretty intuitive.
yeah, that's a good point. That's a good point as to why I did if. So, does anybody have any questions? Did anybody follow along with some of this stuff?
Followed the whole time.
Thanks, Jamil.
None of this trick.
Yeah.
This is,
Yeah,
this
I
is
gotcha.
all new information to me. Never heard of any of this before.
Yeah. So this is stuff that isn't very great on its own for a game. You can't really make a game that's only focused on add force. But using these...
Whoa.
Yeah, okay. Fair enough. But using all of these together, you can get a game that uses a lot of physics using Unity. Because Unity's physics engine is pretty decent. As long as you're not using super high-speed mini golf balls or anything like that.
Whatever. It works now.
Yeah. So I was planning on next week continuing with a little bit more stuff like joints. No, not those joints, but
With those
joints.
joints.
Because Unity has some really neat stuff that let you create hinges and springs and let you string stuff together. And I want to go into a little bit of that, and then next week make a probably platformer using some of the physics options and show how are these actually useful. So stay tuned for that. We'll use some of these. Don't lose your knowledge. Don't forget it.